All right, let's integrate. We are given this integral of the square root of 9 minus x squared over x squared dx. What are we going to do? Well, it's got that square root in it, and we just learned about how to transfer square roots into trig functions, so let's remember that. This looks very much like a squared minus x squared, and if you recall that, that is the sine. That's a sine of theta. So, let's see. What will we do here? Let's let x equal to a, which would be the square root of 9. 3 sine of theta. All right, I'm going to draw my triangle like we talked a little bit about before. Draw your triangle, your right triangle. Put your theta there. If you divide both sides by 3, then sine of theta is x over 3, or opposite over hypotenuse. Opposite over hypotenuse. And you can use the Pythagorean theorem to solve for this side. 9 minus x squared is what that will be. Okay, cool. We're going to leave that. We'll come back to that at the end. Let's concentrate now on rewriting this entire integral into terms of theta. All right, if x is this, look at the numerator. Well, let's take dx. Dx would be 3 times the derivative of sine, which is cosine theta, d theta. Okay, so we have the dx. We can put that in there for that. What would x squared be? X squared would be 3 squared, 9, times sine squared theta. Okay, that's going to be that. And now let's rewrite this root into a trig. Okay, so if you remember, if we're looking at the square root of 9 minus x squared would be 9 sine squared of theta. Factor out the 9, that's a 3. This is going to be 3 cosine of theta based on what we just did. The square root of 9 minus x squared is going to turn into 3 cosine of theta. So, rewritten all in terms of theta. The square root of 9 minus x squared is 3 cosine theta over x squared, which is 9 sine squared theta, times the dx, which is 3 cosine theta d theta. So this is what we're working with now. Okay. 3 times 3 is 9. Divided by 9 is a 1. So these all divide into each other and give us a 1. This leaves us with simply the cosine squared of theta over the sine squared of theta d theta. Now what will we do with this? I'm going to rewrite cosine squared into 1 minus sine squared. Why? Because then I've got a monomial I can divide into each of those and deal with that separately. So let's look at that. Using the Pythagorean identity, this is going to be 1 minus sine squared theta all over sine squared theta d theta. This ends up being, I can split my integrals, 1 over sine squared theta minus sine squared theta over sine squared theta is 1. This is d theta, d theta. Now let's integrate. Okay, 1 over sine squared theta is the same thing as cosecant squared theta. I'm going to think of this as cosecant squared of theta. Why? Because I recognize that. That's somebody's derivative, or close. The derivative of cotangent theta is negative sine squared theta. So this is different by a negative. So I can integrate this into negative cotangent theta minus the derivative of 1 is just theta. All right, plus some constant. So this, we've done our integration. The only thing left to do is put it back in terms of the original variable x, and I do that with this little triangle. I can figure out what I need to know. Cotangent is cosine over sine. So right here, let's see. Let me just copy this down. Negative cotangent of theta minus theta plus a constant. Okay, so tangent sine over cosine. Cotangent is cosine over sine. So this is going to be negative according to my triangle. Cosine square root of 9 minus x squared over sine x minus theta. Okay, how am I going to figure that out? Well, right here, the sine of theta is x over 3. So theta would be the inverse sine inverse of x over 3 plus a constant. So this is my answer right there. Very good. Let's do another one. Okay, the root function has the plus in it. So this is the tangent one. So over here, we'll draw our triangle here. Let's see. Here I'm thinking let's let x equal to a tangent of theta. A is the square root of 4, which is 2. So 2 tangent of theta. That's what we're going to let it be. So now that I've written this, I can draw my triangle, which will look like this. My right triangle, my theta. Tangent is equal to x over 2, or opposite over adjacent, x over 2. So we can use Pythagorean theorem and find out that this side is x squared plus 4. Excellent. Okay, triangle drawn. We're ready to go. Okay, now I'm going to need a dx. Dx is going to be 2 secant squared of theta, d theta. We're going to take the derivative of x. Okay, x squared. I'm going to need an x squared. An x squared is going to be 4 tangent squared of theta, okay? And then the square root of x squared plus 4. That's going to be, the square root of x squared plus 4 is 4 tangent squared theta plus 4. Factor out 4, that's going to be a 2. I'm left with tangent squared plus 1, which is secant squared, so it's going to be 2 secant theta. That's what this is. All right, now I'm going to put all this together in terms of theta. This is going to be the integral of 1 over x squared is this, for tangent squared theta. Square root of x squared plus 4 is this, times 2 secant theta. Dx is this, 2 secant squared theta d theta. And this is what I work with. Okay, let's do it. 2 goes into 2, that's gone. If I want to scoot the 1/4 out, I'll scoot the 1/4 out. That took care of all the numbers. One of these is gone. So I'm left with the secant of theta over tangent squared theta d theta. Now, I don't always know exactly how to proceed. I mean, what ran through my mind was, okay, I know that tangent squared plus 1 is secant squared. I could write everything in terms of secant, but the problem is derivatives of secant involve secant and tangent, and I just got rid of my tangent. So I'm thinking, what else could I do? I'm going to break this down into sines and cosines and see if that helps me. So let's try that. This is going to be 1/4. 1 over cosine. Sine squared over cosine squared. D theta is 1/4. 1 over cosine times cosine squared over sine squared. Keep, change, flip. That's going to leave me with cosine over a sine squared. All right, let's see. Let's see here. That is equal to, what is that equal to? This is a 1/4. This is 1 over sine times cosine over sine. That is 1/4. This can also be called, 1 over sine can be called cosecant. Cosine over sine can be called cotangent. This looks familiar to me. This is somebody's derivative. This is the derivative of cosecant, but it's different by a negative. So we have like a negative 1/4 cosecant of theta plus a constant is what this ends up being, because that's the derivative of cosecant besides the negative. So now we'll just rewrite it in terms of x's. All right. So cosecant is 1 over sine. Sine is opposite over hypotenuse. So in this case, it'd be reversed. So it's going to be negative 1/4 times the square root of x squared plus 4 over x, or negative the square root, that's a constant, x squared plus 4 over 4x plus a constant. So these require thought and remembering things you've done before and not being sleepy when you do it. That's a big deal. Okay, so that's number 2. We got 2 more to go. We're going to do it. Number 3 goes like this. And I think you can see kind of the more you do, the better you get at it. At first, it's just like it's just confusing. Like, why are we doing this? That's kind of how I felt, like, what's going on here? But then the more you do, you're like, oh, this is helping me get somewhere. So the more you do it, the better you get at it. So here's number 3. If we want to integrate x over the square root of x squared plus 4 dx. Okay. And then number 4, and then we're going to be done. Only this guy has limits on it. Okay. We can do it. All right, here we go. What do we think about this guy? Oh, it's that plus one. This is tangent. I can see that. So let's let x equal to a tangent theta. A is going to be 2. 2 tangent theta. Let's draw our triangle. Theta is going to be, let's see, tangent's x over 2, or opposite over adjacent. Pythagorean theorem says x squared plus 4. All right, cool. Now let's rewrite. X is 2 tangent theta. All right. 2 tangent theta. That's my x. Dx is 2 secant squared theta d theta. All right. Dx is 2 secant squared theta d theta all over square root of x squared plus 4. Okay, let's think about this. X squared is 4 plus 4 tangent squared plus 4. Factor out the 4 is a 2. Square root of tangent squared plus 1 is secant theta. That's what we get right here. Okay, now let's clean this up as best we can. One of these 2's will go out. One of these secants will go out. So we're left with 2 times tangent times secant. This is somebody's derivative. This is secant. So this is 2 secant theta plus a constant. Let's rewrite this in terms of the of x's. Secant is 1 over cosine. So cosine is going to be 2. Let's see. This is 1 over cosine. This cosine would be adjacent over this, so it's this over adjacent. So it's square root of x squared plus 4 over 2 plus a constant, or just the square root of x squared plus 4 plus a constant. Okay, let me pause for a second and make sure I didn't miss something. That seemed too easy. No, it was right. All right. Let's do this one. This has got the plus in it. This looks like tangent to me. Again, only it's got some extra fun in it. So let's see if we can figure that out. Okay, for now, I'm going to concentrate on this root form, okay? What this is the cube root of this is 3 halves. So this is the square root of this cubed. So what I'm going to concentrate on is the square root first. Let's rewrite it and then we'll fix everybody else. So just in case I need more room, let me just make some more room for this last one. Okay. what I'm working on. 4x squared plus 9. I'm going to factor out a 4. X squared plus 9 over 4. I'm going to take the square root so I don't have to look at it. Okay, this clears this up for me. I'm going to let x equal to a, which is 3/2, the tangent of theta. All right, that helps. There's my triangle. There's my theta. Tangent of theta, if I were to solve for tangent of theta, I'd multiply by 2/3. This is what tangent of theta is equal to. All right, so that means tangent is opposite over adjacent, or 2x over 3. Pythagorean theorem says this would be 4x squared plus 9. Okay, that's fine. Now, what am I trying to do here? I'm trying to rewrite this guy. So, x squared would be 9 over 4. Tangent squared theta plus 9 over 4. Here's my 2. Factor out the 9 over 4 and take the square root would be 2 times 3 over 2. That's just a 3. Square root of tangent squared plus 1 is the square root of secant squared. So 3 secant theta is what I get right there. Okay, that's good. That's what the square root of 4x squared plus 9 is. But it's being cubed. So when we begin to rewrite this guy, this is going to be 3 secant theta cubed. That took care of that part. All right, if this is x, what would x cubed be? Well, x cubed would be equal to 3 over 2 cubed, or 27 over 8. Right? Tangent cubed. All right, 27 over 8. Tangent cubed. All right, what would dx be? If this is x, dx would be constant, 3/2. Derivative of tangent is secant squared theta d theta times 3/2 secant squared theta d theta. Wow, that's a mess, but that's okay. We'll deal with it. Okay, we have limits on this. We haven't seen that before. I'm going to choose to change my limits up front into terms of theta. Okay, so how am I going to do that? Right here. Okay, right here. If x is 0, this lower limit, if x is 0, I multiply both sides by 2/3, and you get that 0 is tangent of theta. When, for what value of theta is the tangent 0, that's going to happen right here. Sine over cosine is 0. So this is theta. This happens when theta is 0. So my lower limit remains 0. Okay, what about the upper limit? When, let's see, when x is 3, root 3 over 2 is equal to 3/2 times the tangent of theta. What happens here? I can multiply both sides by 2/3, and so then I just get the square root of 3 is the tangent of theta, and I like to think of it over 1. So then if I look at my unit circle and ask myself, where is the tangent or the sine square root of 3 and the cosine 1? This is going to happen right here. This is at pi over 3, where the cosine is 1/2 and the sine is square root of 3 over 2. So I take sine, square root of 3 over 2, divided by cosine, 1/2, I get square root of 3. So this is going to be pi over 3. So I've adjusted my limits for theta. All right. Now let's deal with the integral and the numbers. So I'm going to make more room, so let me just erase the stuff I just did. I still got my triangle. We'll leave the triangle. That's good. Okay, let's see. All right, here we go. Let's deal with this. What can I do here? 3 to the third is 27. Secant cubed, okay. What can I do with that? I can do this. 27, we'll go into 27 one time. I'm left with 3 over 16. 3 over 16 is what's coming out for the numbers. 3 times 1 over 16. Okay. What about some of this other stuff? I've got 2 secants, can take out 2 of those. So I'm left with the tangent cubed of theta over the secant of theta d theta. And so now I want to think about how I want to proceed. Maybe I might separate this. I might have to play around with this a while, but I'm going to try holding one tangent and taking tangent squared and rewriting that in terms of secant, just to see what happens. I don't know what's going to happen, but let's see what happens. So we have 3 over 16. Oh, and I still have these limits. 0, pi over 3, tangent times tangent squared. But I'm rewriting tangent squared into secant squared theta minus 1. Yep. Over secant theta. All right, let's see if that helps anything. I'm going to split this into 2 integrals. So this is going to be 3 over 16, 0, pi over 3, tangent secant squared theta over secant theta d theta minus tangent over secant. Tangent over secant. Let's see what happens here. I can take out one of these. So this is really tangent secant. Oh, I recognize that. This is the derivative of secant. So I can take this guy's antiderivative. This is 3 over 16 secant theta 0 to pi over 3. Okay, now I just got to deal with this guy, 3 over 16. This is tangent over secant. Let me rewrite this in sines and cosines. Sine, cosine. 1 over cosine. Oh, okay. This is not going to be bad. Keep change, but sine over cosine, cosine over 1, the cosines cancel. This is just sine. Okay, the antiderivative of sine is, or negative sine, right? If I want to throw that negative in there, is just going to be cosine. Well, now that I've done all that, now that I've got this all together, I could do this together. I could say 3 over 16 times secant theta plus cosine of theta, evaluate here. So that's going to be 3 over 16 times the secant of pi over 3. Where's my unit circle? There he is. This is 1/2. This is square root of 3 over 2. This is at the angle pi over 3. Okay. The secant of pi over 3 is 1 over the cosine. The cosine is 1/2. So 1 over that is a 2. Plus the cosine of pi over 3 is 1/2. Minus at 0. Here is the angle 0, 1, 0. The secant of 0 of cosine is 1 over the cosine. The secant of 0 is 1 over the cosine. 1 over 1 is 1. Okay. And then the cosine of 0 is 1. Plus 1. This gives me 3 over 16 times 2 plus 1/2 minus 2. 2 minus 2 is 0 times 1/2 is 3 over 32. And that is our answer to that problem right there. And that was kind of long, but you can do it with enough effort.